Hey, Algebra 2, how's it going? Welcome. It is section 1.3. We're going to talk about transformations of function graphs and writing transformation rules. So, let's get started. I got a new learning target for you, so please write that down at your notes so you know what we're talking about today. I can use a transformation rule to relate a pre-image to its image. These may be words that sound familiar from geometry last year. We'll get to those in a little bit. Today we're just going to look at the basics, go over some examples, and really understand what it is we're talking about when I say transformations. Success criteria: you will be successful at the end of the class when we can analyze, compare, and interpret functions. Definitely describe the effect on a graph given a transformation rule. We're going to be talking about that one a lot. And also getting a rough sketch of the result after applying a transformation rule. Pause if you need to. One thing I want you to know, when I say that something is a parameter, it is a constant in a function rule that can be changed. You've probably heard of y equals mx plus b. That's just the regular slope-intercept form that you've been working with since like 8th grade or Algebra 1. Y equals mx plus b, everybody knows it. Y and x are the variables, right? That's the thing that's changing. That's kind of what we're graphing. But this m and b, m meaning our slope, b meaning the y-intercept, those are things that could change. We could have something that looks like y equals 3x plus 4. I mean, that's still a function, just the parameters here. M equals 3, b equals 4, all right? Again, they can be changed to different numbers. And I do want to show you a little bit about that because that's kind of where we're going today. So I'm going to go to this link that's at the bottom here. Again, here's mx plus b. I have it graphed in Desmos. This is a graphing calculator that I love to use. So again, m is a parameter. As it changes, my function also changes with it. Now we have a negative slope. So again, I'm looking at kind of transforming this linear function as m changes. I'm going to set m to be equal to a slope of 2. Another parameter, again, what we just talked about, that b value. These are things that you're familiar with. That b value is going to change your y-intercept, where the function crosses the y-axis. As that thing moves, it kind of looks like it's going diagonal, right? But you have to make sure that, keep that in mind. We're just changing where the y-intercept is because we're moving it up and down technically, right? So here is a negative y-intercept. See how it's down here? As I make b to be positive, okay, now that thing shifted up. It's up here now. All right, that's just an introduction. I just need you to know what parameters are. So this next thing, we're actually going to look at a function and a function rule. So again, review of what function notation is. Here's a function, f of x equals 3x. I like to also write down table of values so I can see this. Would be a good idea to get this first example down in your notes right now, all right? So here's my function, f of x equals 3x. I have a table of values, so these, my inputs and my outputs. So if I input 0 into the function, again, my function takes my input and multiplies it by 3. 0 times 3 is just 0. If I input 1 into the function, multiply by 3, I get 3. 2 times 3 is 6. 3 times 3 is 9. 4 times 3 is 12. You get the idea. I could put in negative 11 and I would get out negative 33 because I just take it and multiply it by 3. Okay, obviously. What if I wanted to transform this function now? So what I'm going to do is I'm going to write a function rule. And I'm just going to say, when we're talking about original functions, we like to use just f. And then when we're talking about changing that function, we can write a new function, and we'll usually use g as like a second function that we're talking about. So when I say f and g, they're just functions. Usually we use f to be the original, and g is like the transformation. It's the second one, right? So here's my transformation rule. I have this new function, g of x, And what I'm saying is that g of x is whatever f of x is plus 9. So take my original function, f of x, the 3x plus 9 over here, and just add 9 to it. So again, what exactly are we doing here? Okay, here is my table of values from f of x. I've just copied them over here. Again, f of x, all it does is take my input and multiply it by 3. This new transformation rule says, okay, still multiply it by 3, but now add 9 onto it. All right, so after inputting all of these, I've multiplied by 3, and now g of x says, just take whatever f of x is and add 9. So 0 plus 9, 9, 3 plus 9, 12. You get the idea here. 6 plus 9, 15, 9 plus 9, 18, 12 plus 9, 21, etc., etc. All right, so if I inputted, I'll just put in, if I put in a 10, f of x says we'll multiply that 10 by 3 to get 30. And then g of x says, just take whatever you got for f of x, whatever your output was, and add 9 to it. So my output, as according to my g of x function rule, add 9, now get 39 there, all right? So that is the math that's going behind this, but what does the actual thing look like? I mean, can we graph this thing and look at both of these and see how the graph is transforming now that we've added 9 to f of x? Pause if you need to get this example down and write down table of values. So what I'm going to do is I'm just going to sketch it and then we'll look at the actual description of the graph. So here, f of x equals 3x. It's a linear function. It's got a slope of 3, goes through the origin. It should look something like that. Agree? Over here with g of x, all I did was I took my function f of x, which is still should look something like that, and all I did was add 9 to everything. So if I add 9 to everything, I should just take this and move it up. And that's what we saw. We had 0, we add 9, we move it up. We had 9, we added 9, we moved it up to 18. So all this is doing is just taking every single point on this line and adding 9 to it. So I'm moving it up 9 units. So my g of x function rule should look something like that. It should just be another line with the same slope, but moved up a little bit. Let's take a look at what that would look like on Desmos. All right. So on Desmos here, what I have graphed is the blue line. The blue line is our original function, f of x equals 3x, all right? So that's up here. Don't worry about these. These are the transformations. I'm going to be turning them on so we can see what they look like. The transformation that we had was f of x plus 9. So, and in here it corresponds to this one. It says g of x equals f of x plus a parameter. So what I'm going to do is I'm going to make a equal to 9. I'm just describing like what this process is. All right, hang on, let me put it back at 0. There we go. So if I turn on this transformation, and f of x plus 9 is about right there, all right? So again, that's what we see. We see our original right here. The transformation, which is graphed in red, this one right here, all I did was take my original, move it up 9 units, all right? So that is what we call a vertical shift. So if my parameter, and in this case my parameter is 9, if I'm adding something onto my function, that's what we call a vertical shift. I'm just taking everything, moving it up. If it was f of x minus 5, now my parameter is minus 5 and negative 5, it would just take everything and move it down. So that would be what we call a vertical shift down, all right? Again, we're just getting the basics of this. So let's do a couple more examples. All right. So again, I'm sticking with the original function that we had just so we can make things easy. That table of values is right over here to the left, f of x equals 3x. Take my input, multiply everything by 3 over here, all right? So, what's happening now? Now in my transformation rule, g of x equals f of x minus 10. I'm going to go back just a second. Notice how on the previous one we had our parameter on the outside of the function, right? I took my function, or I took my input, I did whatever the original function wanted me to do, and then I added 9. So I changed my original function after it was done doing its function thing, okay? Here, my parameter is on the inside of my function, right? It's not on the outside, so I have to make a change before I even input x at all. So what's that going to look like? And this is how I think the table of values makes the most sense. Here I have that change before I even get to it. So here's my inputs. According to this function rule, I need to take x and minus 10 from it. So over here, my input is 0, minus 10 from that, I'm going to get negative 10. Minus 10 from 1, you're going to get negative 9. Minus 10 from 2, you're going to get negative 8. All right, you see where I'm going with this right now? And then g of x says, all right, fantastic. You've taken your input, you've minus 10 from it. Now I want you to apply the function. Apply the multiply by 3 function, all right? So I've minus 10 for my input, done. Now g of x says, just multiply everything by 3 now. Okay, so negative 10 multiplied by 3, negative 30, negative 9 multiplied by 3, negative 27. Okay, you see where I'm going with this? All right, so that change was done before we even multiplied by 3. All right, okay, so here again, minus 10 and then apply the function. Minus 10 and then apply the function f. So that's what the transformation rule G is doing. So again, what exactly is happening when we do that? I'm going to pull up the Desmos graph. We'll take a look at it again. So here in Desmos, again, I have that original f of x equals 3x. What did we say? X minus 10. So I'm going to go find this one right here and turn that on and say, all right, g of x equals f of x plus a. So I'm going to make a be a negative 10, so we have that correct parameter. And see what happens. So here's about the original, here's about the original function. When I make that parameter a equal negative 10, all right, now my transformation is over here. So this is the graph of 3x. This is the graph of the g of x equals f of x minus 10. So what happened to my original? Just got moved over 10 units, right? I went from here, I shifted it over here. So that is what we call a horizontal shift to the right 10 units, okay? So now you're seeing the math behind it, you're seeing the actual transformation of the graph. We're gonna start applying these rules on a daily basis. Was that all I had? Okay, that was all I had because it is a short day and I wanna make sure you get some notes done. It is a lot. If you need to take a minute and just write everything down from here, do it. Normally when we're in class, I would print this off for you and hand it out and say, hey, tape it in your notebooks because this is a lot. So find a place where you can have this handy. If that is in your notebook, fantastic. If that is, you're just gonna make sure to bring up this slide every once in a while when you need it, that's totally fine. We're gonna talk a whole lot more about these, but today we talked about the horizontal shift and the vertical shift, all right? So I like this picture because it has the description of the transformation. It has the function rule. So again, this was kind of where we said, g of x equals f of x plus 9, or g of x equals f of x minus 10, all right? So we have this kind of function rule, and then we have a description of what it's doing. So that first example that we had g of x equals f of x plus 9. Well, we saw that it was a shift up 9 units. And here they have parameters. The parameters that they're using is k. They're just using another variable. So here it says a shift up k units because I have f of x plus k. All right. So again, we're going to cover, so today we covered these top two, the horizontal shifts and the vertical shifts. When we come back, we'll talk about the reflection and the rest of these. So this is just part 1 of today, but I think that was a lot of information. So function transformations. This is what we were talking about. Woohoo! All right, pause if you need to. Otherwise, oh, this is just another thing. Again, review, you were given a function, f. When we've got an input x and we have an output f of x. Again, we've talked about these ones before. Transformation rules are either making a change on our input or our output. And again, we saw that originally. Here was a change on our output because we applied the function first and then added 9. Or here was a change on our input. First we had to change whatever the x input was, and then we applied the function, all right? So again, just kind of getting used to that notation. Otherwise, just show me your notes. Show me your notes from what you did today. We will finish this off when I see you tomorrow. Thank you, guys.